Now I am taking one problem where we will use the circular permutation. In fact, if there are 10 persons, they want to be arranged in a queue. There are factorial 10 ways. But if there are 10 persons would like to sit around a circular table, there are factorial 9 ways. Out of an object, their linear arrangements are factorial n and their circular arrangements are factorial n minus 1. It's always because for the circular table arrangement, we have to keep fix one person to make the different arrangements. So the question is on the theory of selection and arrangement, both, but circular permutation will be used. In how many ways can a dinner for 21 guests be hosted on two round tables which can accommodate 16 and 5 persons respectively? One businessman invites 21 persons and there are two round tables. On this, around it how many persons can sit? 16, and around this small table 5. So 21 guests. So number of ways is 21C16. First 16 guests will be selected from the 21 guests. Then remaining how many are left? 5. And guests are how many? 5. So this become 5C5. This is the selection of the first 16 guests for the first table, and then for 5C5 into, because these 16 guests first have been chosen, then they can be arranged on the circular table. So circular permutation, circular arrangement will be 1 less than what available, that is factorial 15 into 5, that is 5 guests around the table, so that will be factorial 4. So this is the total possible arrangements that a person can invite 16 guests, and he is having two round tables on first capacity of 16 and another capacity is what? 5. So the answer will come 21C16 into 5C5, because all 5 are to be selected, into factorial 15 into what? Factorial 4. So this is the total way of arranging the guests.